Hi, in this video we're going to look at solving exponential equations, and we have two case scenarios, and we're going to mainly focus on the equal bases in this video. But in some situations you'll be given equal bases, and in other equations you'll be given non-equal bases. Sometimes even when you're given non-equal bases you can convert them to equal bases. So we're going to take a look at this branch of solving exponential equations with equal bases, and we'll come back to this branch in the next video. But let's just take a look. If you have equal bases, 5 and 5, then you must know that the exponents are also going to be equal. So it's common sense. It tells you if 5 to the x equals 5 cubed, then x must equal 3. In a situation that may not be so obvious, we have equal bases, so the exponents must also be equal. In this case, 1 minus x has to equal 4. If that's the case, we're going to solve for x by simply isolating the variable. And negative x is equal to 3, so positive x is equal to negative 3. And you can substitute that back in. 1 minus negative 3 is equal to 4, and that confirms the equivalency. Now if we take a look at the next problem, again, in this situation we don't have actually equal bases, but we can convert them to equal bases because 9 is equal to 3 squared. So in this case, if we just simply make one little conversion, that to 3 squared, we have equal bases, therefore we have equal exponents, and x is equal to 2. Now let's take a look at this problem right here. Okay, don't have equal bases, but 27 can be converted to 3 cubed. And again, this is where you must become familiar with your powers, your bases, and whatnot. So now that you have equal bases, you must also have equal exponents. So 2x minus 1 is equal to 3. And we're going to simply solve for x, add 1 to both sides. 2x is equal to 4, and x is equal to 2. And again, you can substitute this in. 2 times 2 minus 1 is 3. 3 cubed does equal 27. In this particular problem, we have maybe some more advanced type questions. Again, all this is saying is that you just need to become familiar with your bases and your exponents so that you can make these conversions and recognize them. In this case, we have 3, and I know this doesn't look like it, but it's x squared minus 3x, that's the power, is equal to 81. Well, 81 happens to be 3 to the 4th. So now I can set my exponents equal, and you'll know notice it's a quadratic equation, so I'm going to set this equal to 0 and solve it. And yes, you guessed it, we have two answers this time. Factors of 4 that equal 3. For 1, we want a negative 4 and a positive 1 to get that negative 3 in the middle. And now the zero product property states if you multiply two numbers together and the answer is 0, one of the numbers has to be 0. So the number that would make this 0 would be 4 and negative 1. Okay, in like manner, this one right here can't convert 8 to a base of 4, but 4 and 8 can both be rewritten with a base of 2. And this is raised to the 2x squared plus 2x power is equal to 2 cubed. Now we know that a power raised to a power, we can multiply those. So 2 times 2x squared is 4x squared plus 4x. And it equals 2 cubed. Now that the bases are equal, the exponents must also be equal. So we know that 4x squared plus 4x has to equal 3. This being a quadratic equation, we need to set it equal to 0. We'll subtract 3 from both sides. And now you have a few options here. You can use the quadratic formula if you'd like to solve this. That is the sure way of getting this. Or you can just plug and play, just kind of look at this from the vantage point of you want factors of, well, your first two have to equal 4 and your last two have to equal 3. So again, because I have worked this out beforehand, I know that 2x and 2x, and then the last two factors have to multiply out to equal 3, since 3 is prime, we're going to have 3 and 1. We just got to get those numbers in the right place. I want a positive 4x. So more than likely I'm going to have a positive 3 here and a minus 1 here. And let's just check this. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Hold that. 3 times 2x is positive 6x. When you add it with a negative 2x, you get that positive 4x in the middle. And then 3 times negative 1 is the negative 3. The zero product property again states if you multiply two factors together and the answer is 0, one of the numbers has to be 0. So in this case, x is going to equal negative 3 halves and positive 1/2. And again, you can set those equal to 0, solve them, and this is what you're going to get. This third example, okay, we have a fraction. And I notice that I have a 64. So I'm going to start by rewriting that 64 as 1 over 4 cubed. Next, what I'm going to do is I'm going to write this as 4 to the negative third. I can change this to a non-fraction just by simply changing its position in the fraction. We know if it's happy in the downstairs, it'll be sad in the upstairs, so this is an equivalent form. Now that the bases are equal, we can set the exponents equal to each other, and when I do that, I get x plus 1 is equal to negative 3, and I can subtract 1 from both sides, and x is going to equal negative 4. And that kind of concludes this video for solving exponential equations when the bases are equal. I will be discussing when the bases are not equal in the next video.